Hi, and we are now recording.
Oh, are we?
Yep. This is
right.
podcast 5.4. We're working on naming acids.
Yep.
So in 5.3, we were naming ionic compounds. And what else did we work on naming? Polyatomic ions.
Polyatomic ions, yep.
Right. So we're just moving on from there. We're hoping that our students have created a naming card by now.
That would be good.
Yeah, so if you haven't done that, go talk to your teacher about your naming card. Or go to my website or to our Moodle site and download your own, because then you can print it in full color.
That's right. Then it looks really good.
Yep, I'm printing them in black and white, so get over it. All right, let's work on naming acids. We have two types of acids. One is the binary acids. So if you look at what an acid is, you see it starts with hydrogen.
Right, always.
Always. So a binary acid is where we would have some anion with hydrogen, no oxygen. So hydrogen and a nonmetal, that's called binary acid. And then a different type of polyatomic ion, I already wrote that over here, it's called an oxyacid. So if you look at your list of polyatomic ions, you'll notice a lot of oxygen.
And that's why we call it oxy.
Yep.
Yep.
Okay, so help us out here. With these two that I've listed, HCl and H2SO4, then which one is our oxyacid?
That would be disulfuric acid.
Why do you think that?
H2SO4, because it has oxygen right there.
Right, so this one's our oxyacid. That was pretty simple.
Very simple.
You like how I ask you easy questions?
Yeah, when they're right there on the board for me, it's even better.
Yes, exactly.
Yep.
Okay, so we have binary acids where the naming depends on the state of the acid. So if it's not aqueous, it's not an acid.
What does aqueous mean?
Oh, good question.
Ah,
Aqueous means dissolved in water.
that's right.
And we talked about that in Unit 1, but I'm sure glad you asked that important question.
Yeah, because I keep getting asked that question.
Right,
so,
and so it looks like this. If it's written after a chemical formula, it has an AQ in parentheses.
Yeah, and
Right.
you know, I tell everybody aqua, AQ, aqua, that's water.
Right,
So there we go.
exactly. Speaking French, Latin.
That's right, all of that.
Yeah, Romance languages. Okay, so here's an example of HCl. If it's not aqueous, it might have G behind it, which stands for the gaseous phase. Then we just call it hydrogen chloride.
Because that's covalently bonded if it's a gas.
Right, and it's two nonmetals, right?
Yep.
And if it is aqueous, then we have to name it this way. We put hydro in the beginning, then we name our nonmetal, then we put ic at the end.
Right.
Okay, so our nonmetal, hydrogen doesn't count as a nonmetal, but it doesn't get to count here as our anion either.
Right.
All of our acids start with hydrogen. We're talking about this piece. So the chlorine, we're just going to use chlor.
We drop the ene and add the ic.
Right, we're just going to use the root of this. So we call it hydrochloric acid. Now let me put it all together. Hydrochloric. And then all acids have to have the word acid at the end of their name.
Right. That way we know it's an acid.
Oh,
Even
look,
though we would
I
know
already had
it's
it typed
there.
up.
Oh,
Hydrochloric
man.
acid. I wrote that extra for nothing.
Practice on the board.
Yeah, exactly.
Yep. The bamboo.
Okay, well, here's some examples. Here's a solid compound HBr,
Okay, so it's not aqueous.
right? So it can't be an acid.
So therefore it'd be hydrogen bromide.
Okay, do I have to say monobromide?
No, you don't have to say mono.
Right, because there's
Except-
only one way to make this with hydrogen.
Right. Yep. So
Okay, here's something that is aqueous.
HI.
So we start with hydro.
hydrogen. Hydro. Yep, the root. And then I is what is it? Iodine. So
Iodine.
we say iotic
Iotic,
acid.
because we have to have the word acid.
Yep.
So notice there's a space here between hydroiodic and the word acid.
Yep.
All right,
I
what's
see that.
next? Aqueous.
Oh, another aqueous.
So it's got to be an
Ooh,
acid.
Wow, look at that. S is sulfur.
Okay, so I'll
Which-
start with hydro.
Just for what we've talked about in the past is in family 16, which means it has 2 valence electrons. That's why hydrogen has to have, we have to have two hydrogens. So, but it is aqueous, and it's sulfur, so it's hydrous sulfuric acid.
Okay. I don't call it hydrosulfic.
Nope.
No, because for pronunciation's sake, you
Yeah.
would drop the iodine part, but not the sulfur part.
Right.
So,
Drop the I, not the
right.
Yep.
Here's another H2S. Isn't this hydrosulfuric acid too?
Oh no, because it's gas.
Aha. So we don't name it like an acid. We just name it like a regular old compound. Do I call it hydrogen disulfide or hydrogen sulfide?
Sulfide.
There's only one way to do this.
Right. Yep.
Hydrogen sulfide. So if we called it disulfide, that would just be a redundant name.
Yeah, but not only that, the sulfide, if you look, is only an S, not a 2. Would it be dihydrogen sulfide?
Oh, okay. I see what you're saying.
Mm-hmm.
Yeah. So we're just going to call it hydrogen sulfide.
That's right.
Yeah.
Yep.
All right, time for oxyacids. These have different naming rules. So if you see oxygen there, then first of all, it's always an acid no matter what state it's in.
Right.
So even if it's not aqueous, we still name it as an acid. So we have to figure out what polyatomic ion we have. And we're going to replace something that says 8 with the ending ic.
Yep.
And change the root if you need to for pronunciation's sake. Then we add acid to the end of the name.
Yep.
I think we're missing something. We change 8s to ics. What if I have something that says ite?
Right.
What would we change that ending to?
Ooh. Would that be OUS?
Uh-huh.
Sulfus?
Right. So if you could remember I ate something icky, then you'll remember 8s become ics. And then you have to just know what an ite does.
And then if you take a wrong bite, it could make you nauseous. So there's your
Oh, bites make you nauseous.
There you go.
Clever.
Yeah.
I'm so glad you've had some experience with this.
Yeah.
So here's our example.
Yeah, I was about to say I've been around a day or 2.
Yeah, well, we won't talk about how many days.
No.
All right, I want to bring up my naming card. So, okay, Mr. Henderson.
Okay.
Now I have H2SO3. My
SO3.
first step says name the polyatomic ion, but I'm not sure which one this is. Should we look at the ion card?
Let's look at it. SO3.
Oh, I need to scoot over.
Just a little bit, yep.
Because they're all in alphabetical order here. I thought that would be the easiest way to find things that we need. So I see SO4 and I see SO3.
Right. And so SO3 is sulfite.
Sulfite. All right, that's an ite. So that means I have to change its ending to us.
Yep.
Okay, so I'm going to start with the name of the polyatomic ion.
Right.
Instead of calling it sulfite, I'm going to call it sulfur us. And then what do I do?
And then you got to say acid.
Okay, I don't call it hydrosulfurous.
Nope, we just call it sulfurous acid.
Right, because if there's oxygen
The
there...
NHS meeting is starting immediately. NHS in Miss Kincaid's room is starting immediately.
If there's oxygen there, then we don't start with hydro.
Right, we just leave it as sulfurous or sulfuric or whatever the case may be.
Right, so we identified first that we had sulfite, and then we know this rule has us changing the ite to us.
Yep.
So, oh, look, even
Did it again.
I should talk less or write less. I
Good
don't
to
know.
see sometimes.
I guess so.
Yep.
Okay, well, we've got a few acids to name. NO2. Should we look at our naming
Let's
card?
look it up. Yep. Always good to look those up.
Oh, gosh.
NO2, nitrite, another ite.
Oh, where do you see? I see it now. Okay, I missed it. Right here, nitrite is NO2.
Yep.
So, ites become us.
Us.
How's nitrous acid sound to you?
Sounds perfect to me.
All right. Oh, here's a tricky one.
Ooh.
ClO4.
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 Oh, it's right there under oxalate.
Under oxalate.
On the right-hand column.
Oh, wow. It's hiding from me. It's
Yeah.
not in the C column because it doesn't start with C.
Right, it starts with Cl.
Yeah.
But the word starts with P, perchlorate.
Perchlorate. So that per prefix, we're going to have to keep it in
Right.
the name of our acid. So let's go back to...
Because it defines a little bit.
Okay, so this is called perchlorate. So I keep that root, perchlor, and then 8's.
8's becomes X.
Right, I ate something icky. So perchloric acid, and that's it.
Mm-hmm. Once again, no hydrogen. We don't need it in the oxides.
Right,
Or the
for oxyacids.
oxyacids. Excuse me. Jeez.
Oops, I was looking for PO4. So back to our naming card. Oh, my thing's in the way. Get out of the way. PO4.
PO4 is phosphate.
This one?
Yep.
Okay,
That's the one.
there it is.
And that's why we have 3 hydrogens, because that 3 negative on there.
Yeah, so PO4 is phosphate. 8
It's an
becomes
8
ick. Oh,
Yeah.
can't spell. Phosphate. Oops, ick. Phosphoric or phosphoric?
Phosphoric.
Okay, starting over. Phosphoric. That sounds better.
Yeah. And you just got to know that the P is phosphorus, and so that's why we got to go ahead and bring that root back in, the whole word.
Yeah, right. P is phosphorus and K is potassium.
Right.
Don't get those mixed up.
Yep.
All right, what is CO3? This is the wrong formula. I need this to be
H2CO3.
H2CO3.
Yes.
All right, CO3. Let's find that guy. I've got too much writing. I'm going to
Yes.
go ahead and clear it.
Okay, that's fine. So CO3, anybody see it? There it is, carbonate.
I
Look
have
at
it right up at the
there.
top. CO3, carbonate. Oh gosh. So carbonate, 8's become X.
Right.
So carbon.
Carbonic. I'm sure
Hey.
some people have heard of that one before.
Yeah, that stuff is in your fizzy soda.
Yep.
Carbonic acid. Okay,
All right.
good. So we can write the name when we get the formula.
Right.
Can you do it backwards?
I can.
Well, here, I bet you I can. I've practiced. Okay, so now we're going to go backwards, and we're going to write a formula from the name.
Right.
Okay,
There we
so here's our steps, because this can get challenging,
Right.
but we can handle it. Identify the anion involved in your formula.
Right. Now, just for a refresher, anions are what? They're negative ions. A negative ion.
And the cations are positive.
Yes.
Okay, so we've identified the anion involved, and if the acid starts with hydro, then we know we don't have a polyatomic ion.
Right. And we know
So,
it's,
no
therefore it's not an oxyacid.
Right. So if there's no hydro and the name ends with ick, then the polyatomic acid has to end with 8. So we're just taking what we learned and going,
And going
backwards.
backwards. Yep.
Okay, if there's no hydro and the name ends in
Us.
us, I'm doing this backwards, forwards,
Then it would be an ite.
and it's an ite for the polyatomic ion.
Yep.
Okay, and we got to know which ion it is so we know how to write the formula, right?
Right.
Okay. If there is a prefix on the acid name, then there's a prefix on the polyatomic ion.
Right.
Like our perchlorate that we just
Perchlorate.
did,
Yep.
that had that prefix per. Oh, here's another one. Hypochlorous comes from hypochlorite. Notice the ending and the prefix.
Yep. They match up.
Yeah. Okay, so we use the charge of the anion that we've
Right.
identified
Is
to
it a
tell
plus
how
one,
many
or
hydrogens.
-1, -2, whatever it is.
Yeah, and this is the easiest part. You don't have to crisscross charges. Just look at the charge of the anion, and that tells you how many hydrogens to
Yep.
use.
So you better have your polyatomic ion card ready and handy.
Yeah, no, in my class, my kids get to have that always
Yep. Mine too.
on every test,
Yep.
even the
From now
final.
on.
Yes, I
Yes.
love it. That's going to be your most handy tool.
I still have to refer to it a lot.
Oh, me too.
Yeah.
I've memorized most of them because my AP chemistry class made me do it.
Yep.
All right, so now we're going to do some of them.
Okay.
I bet there's more than this on the kids'
Sheets.
note-taking sheet,
Yep.
but we're going to do some, not
Yep.
all.
That works.
Okay, so carbonic acid we just did. We know that was carbonate,
Yep. Because it's ick, we go with carbonate.
and that has a 2- charge.
Right.
So how do I write the formula for this
Okay.
acid?
Well, since it's an acid and it has an O.
Mm-hmm.
Okay,
It's
but
an
acid we
oxyacid.
always start with H.
Okay.
But H has a +1 or a -1 charge. In this case, be a +1.
It better
So we
be.
need 2 of those.
Yeah, because if I put a minus charge on this, it wouldn't stick to carbonate.
Right.
All
There would
right.
be no attraction to them.
Yeah. Let's do this hard one over here, acetic acid.
Acidic.
Acetate is C2H3O2 with a -1 charge.
Wow.
Yeah,
Okay. That's a hard one.
that one's,
But once you get into it, it becomes fairly easy.
yeah. Now, I knew I was looking for acetate because I saw this ick ending.
Exactly.
All right, so now if I know this is a -1
Then that
charge.
tells us we only need 1 hydrogen in front of it.
Oh, well, then here we go. Get rid of that charge because now we're balanced.
Yep.
It all adds
And
up
we're
to
good.
0. So that's it. That's the formula for acetic acid.
Mm-hmm.
Have you ever eaten acetic acid before?
Oh, absolutely. Quite often.
Me too. I like it.
Mhm.
Yeah, on my
Yeah.
salad,
I
in my
like-
cucumbers.
Mhm. Yeah, definitely on my cucumbers because, then we get a good pickle.
Exactly.
Yep.
You can ask your teacher what acetic acid is. How about hydrochloric acid? This one's in your stomach to
Yeah.
digest your food.
Well,
so
since it's a chloric, that means it's got to be a chlorate.
Right, except it starts with hydro.
Right.
So I can't
So-
have any oxygens.
Nope. So it has to be.
So we need the chlorine.
Which has
Okay.
a charge of 1 negative.
Right, and if you don't remember, come back to your ion card and find chlorine over here. Look, there it is.
Yep. Got a 1 minus.
1
There we go.
minus. So you don't even have to memorize those.
Nope. And then you put 1 hydrogen in front because it has 1 plus.
Yeah, so
there
a
we
1
are.
plus and a 1 minus is perfect.
Yep.
Okay, we did phosphoric acid before, H3PO4, because phosphate had a 3 minus charge.
Right.
So I'm glad you pointed that out.
Yep.
We'll let everybody else look up arsenate and nitrite.
Nitrite, yep. And
Okay.
sulfurate or sulfate.
Yeah, sulfate. Oh, and then here's hydro, sulfuric. So that means this one has no oxygen.
Right.
So what I want to see in class is that you did the other ones that we didn't do. I'm
Yeah.
going to check.
I will as well.
All right, fair enough.
All right.
Now we're going to do one other kind of compound that's common. We just don't think about it very much. It's called a hydrate. So a hydrate refers to a compound with a specific number of water molecules associated with each formula unit. So let's look at an example. This one is calcium acetate heptahydrate.
What's hepta? Is it 7?
7, right.
Yeah.
Okay, so what this means is that in the crystal structure of calcium acetate, there are 7 water molecules associated with
Right.
that particular crystal structure. That makes it more stable.
Yep.
Okay, so the other form of this molecule is called the anhydride, the pure crystalline form without water. So we just call that one calcium acetate,
Or
or sometimes it's called anhydrous calcium acetate.
Right.
And depending on the compound, if they just say calcium acetate, then they are probably talking about hydrated,
right.
because that one automatically just absorbs water.
Yep. So we got to make sure we say anhydrous.
Yes, exactly. Oops, wrong button. So how do we name these bad boys? Now I've clicked the wrong button. Okay, so if we had, I just wanted to show you what a hydrate is. I'm sorry.
Yeah, that's
We're
fine.
not ready to name yet. I just want to show you what this does. So cobalt chloride in its anhydrous form, let me show you.
Oh, isn't that pretty? Nice and blue. And
Yeah.
Yep.
Now let me show you the hydrated form.
okay. Oh, wow.
Very different.
Yeah.
Cobalt is one of those highly colored transition metals. I really like cobalt.
Yep.
But guess what they use this particular substance in?
Well, I don't know. What do they use?
Well, it's been a while since you've potty trained any kids. Your kids
a long
are
time.
big kids.
Yes.
They use them in pull-ups. So when a kid wets themselves, it changes the color of the little cartoon thing on their pull-ups from blue to pink, and you know they need change.
Yeah. Well, I never used pull-ups, so I
Yeah,
didn't
well,
know that. That's kind of interesting.
Back in
though.
the day. Right. So
Back in the day. Yeah.
this is a good example of how to use a substance and its properties to tell if there's moisture around.
Yep.
So there's lots of places where you might need to know if there's moisture, but in a pull-up, the little kid, would have Bugs Bunny or whatever, shows up in this new color, and he would be sad because that means he wet himself in.
A Bugs Bunny, a pink Bugs Bunny.
Oh, no good.
That's no good.
No good. No. At least at my house, there were a lot of little boys that needed potty training. So that meant, no cowboy boots if you wet yourself. So here's writing formulas from names. I think we already, nope, this is for hydrates.
Yep.
Again, identifying the ions involved.
Yep.
Crisscross the charges to write the formula like we normally do. And then we use your ion card. And we use parentheses.
Right. Yeah, that's it. Ian instead of parentheses is parentheses.
Of course.
Yeah. You knew that. Just testing, right?
Yep. Checking the spell checker.
Yeah, keep that ion card available.
All right. So that means if I have more than one hydroxide, I got to put parentheses around it.
Yep.
To keep that group together.
So that we know that if we have two hydroxides, that it's 2 for both of them, not just the hydrogen.
The 2 there.
Yep.
Okay. So then we identify the number of waters with a dot, like this.
Yep.
Okay. So
and multiply, right?
Yeah.
Yep. Okay.
So this is going to be a little bit tricky.
Yes.
Oh, and the prefix, I forgot that. Hydrate. Oh, the prefix for the number.
Yes.
For the number of waters.
Right.
Okay, now I think we've got this. So let's figure out what magnesium should be.
Well, if you magnesium's Mg.
Yeah, and if you look on the periodic table, it's in the second row. So that's got to be a 2+.
Right.
Sulfate, we saw on our ion card earlier, SO4 with a 2- charge.
Right. So we got a 1-to-1 there.
Yeah, they
cancel each
other out. So MgSO4. Now let's deal with the water part.
Hepta, once again, means 7, not the 5 I said earlier.
And then hydrate.
HOH.
Yeah, or water.
Or water.
Ta-da!
HOH or H2O.
Yep. Now we've got that cobalt 2 chloride, the pink and blue stuff that I showed you. This hydrated form is pink.
Yep.
Okay, cobalt 2 means it's the kind of cobalt with a 2+, not that there's 2 of them.
Right.
It's the kind that's...
The Roman numeral tells you the charge.
Yes, exactly. Yep. And then the charge of chloride we saw earlier too is a -1.
Right.
So now I'm going to crisscross the charges. I need 1 cobalt and 2 chlorines to make this formula. Okay, and then how many waters do we want?
Hexa. Ooh.
Like a hexagon?
That's right. That makes 8.
You're messing with me.
Yes, I am.
How dare you? Hexa means 6.
Has for a long time.
And so we have 6 waters.
Sergeant, if you're in the building, please come to the office. Kaylee, Sergeant,
I think we're about done.
Please come to the office.
You're right.
Oh, except now we have to go backwards. No, we're done.
We're done.
Ta-da! We'll go backwards in class.
Yep.
All right, good. This takes some time to work it through, so you need to practice.
Practice, practice, practice.
See you guys.